Now, let's discuss the third type of radical equation. In the second type of radical equation, you had radical signs, you had radical terms on both sides of the equation. And in the radical signs, you had linear terms. So one basically variable term and one constant term. Over here, you have similarly, you have radical terms on both sides, except that under the radical signs you have quadratic terms. So naturally, your first instinct is to factorize the quadratic terms. And upon factorizing the quadratic terms, you get this equation here. Now, you can write this down like this as well. So, like two terms being multiplied under a radical sign can be written down as the two terms separately under radical signs being multiplied. So basically, this term here can be written down like this. Now, what you'll do here is you'll basically see that the x minus 1 whole under root term is common in all three terms. So, first off, you'll basically take this term on the left hand side because all radical terms must be on one side as per the rule. So, you've taken the term on the right hand side to the left hand side and put a 0 on the right hand side, and now you've taken the under root x minus 1 common in all three terms to get these two terms. So this whole term is either equal to 0 or this term is equal to 0. So basically, your very first solution is x minus 1 is equal to 0, so x is equal to 0. This is your first solution of the equation. Now the other solutions you must find by solving this. What is this? If you look closely, this is the second type of radical equation. Linear terms under all radical signs. So refer back to how you actually solve this. You'll take the square on both sides to eliminate the radical signs. Now, simply, if you remember, this is just like basically this term here. You'll basically solve in a way like a plus b whole square is equal to a square plus b square plus 2ab. And that is exactly what we've done here. This is a square, this is b square, and this is 2ab. Now, upon eliminating the radical signs here, you get this. And you'll take this entire set of numbers, I guess, on the right hand side because only the radical term must be on the left hand side as per the rule. Now, or as we've done here, we've taken the radical term on the right hand side. Basically, the radical term must be on one different side from everything else. Now, upon doing all the calculations, you get this equation here. You'll square both sides so as to eliminate this radical sign. So upon doing that, you get this, and then after all these calculations, you'll get this quadratic equation. Clearly, the factorization of this equation is way too difficult. So you'll just put in the quadratic formula. This 56 is A, this minus 84 is B, and this 31 is C. So after putting it in the quadratic formula and doing all the calculations, basically you'll get this. So you get two solutions here. One solution is 21 plus under root 7 over 28, and the other solution is 21 minus under root 7 over 28. So now you must check for the extraneous roots, because remember, these radical equations are deceptive and devious. So first of all, the very first solution that we found, x is equal to 1, put that in the original equation given in the question. You can clearly see that the left hand side is equal to the right hand side. So this is a solution of the equation. This is not an extraneous root. Now, the second solution that we found, which is this one here, when you plug it into the same equation given in the question, you can clearly see that the left hand side is not equal to the right hand side. So this is an extraneous root. This is not a solution. And the third solution that we found, when you plug it in the original equation, you can see that the left hand side is not equal to the right hand side. So it is also a extraneous root. It is not a solution. So the solution set is basically x is equal to 1, and that's it. That is the only solution of the equation.